All right, today we're looking at section 6.4, which is linear programming. Now, with this, we're essentially just taking word problems, changing them into linear inequalities, and then graphing them. So we're essentially changing word problems into linear inequalities. So, for example, Jack has to buy pop for a family movie night. They need at least 3 liters of root beer and at least 6 liters of Dr. Pepper. Jack has enough to buy a maximum of 12 liters. Show Jack graphically what combinations are possible. So first thing we might want to do is define our variables. So I might say my X is my root beer, and my Y is Dr. Pepper. Now coming up with my grid or my axes for my graph, I know I can't have a negative amount of either of those, so that enables me to utilize Moses grid. So on here, I would have my X, which is my root beer, and my Y, which is my Dr. Pepper. Now, first thing, they need at least 3 liters of root beer. So that means X must be equal or greater than 3. So we'll start by drawing that in. So here's our X value of 3. Equal or greater, so it's solid. We know equal or greater would be to this side of it, so we'll shade that in. Next, we were told that they needed at least 6 liters of Dr. Pepper. So they've got Y is equal or greater than 6. So Y is on this axis, so let's see, 1, 2, 3, 4, 5, 6. We know that that's going to be a horizontal line because that's a Y equals. And then because we're larger in it, we're going to shade above our line. So far we can see our solution area is this rectangular area here. However, we still have one last restriction, which was they have enough to buy a maximum of 12 liters. So that means that 12 is equal or less than X plus Y. If we rearrange that, 12 minus X is equal or less than Y. So we have a Y-intercept at 12 and a slope of -1. Now, if I do a test point of 0, 0, 12 minus 0 is equal to us. Now I do realize I made a slight mistake earlier on because earlier at x plus y is equal or less than 12, which would mean that these add up to be more than 12, which means I put that inequality in the wrong direction. So we'll just go back and change the direction of those inequalities. So we've got 12 is equal or greater than 0, which is correct. So therefore, test point of 0, 0 would be part of our solution. So essentially, this triangle here is our solution area. Every point within here would give us a possibility that satisfies our inequality. So for example, if I selected this point here, that's 7, so we could have 3 root beers, 7 Dr. Peppers. And that would work with the constraints we are given. Next example, on a change in inequalities graph, John the farmer is going to plant corn and beans. He has enough to plant 4 acres of corn and enough for 6 acres of beans. He has 8 acres of land total. So I might say that corn is X, beans are Y. We'll draw out our grid. Seeing we're dealing with fairly small numbers, I might space this grid out a bit more than the last one. Okay, so we said corn was our x-axis, beans was our y-axis. Now we have to come up with some inequalities. Okay, so first thing, he has enough to plant 4 acres of corn. Corn we said was X, so therefore X has to be equal or greater than, or sorry, he has a maximum of 4 acres. So we know that X has to be equal or less than 4. So we'll draw in a vertical line where X is 4. Now equal or less would be to the left side of that. Now beans, on the other hand, we had 6. So we've got Y has to be equal or less than 6. So horizontal line at 6. We're going to be shading below that because every Y value below that is less than 6. So we can see so far our combined solution areas in this area here. And we have our last inequality, which it says he has 8 acres of land. So that means that x plus y must be equal or less than 8 acres because we can't plant more than he has land. So we've got y is equal or less than negative x plus 8. So we have a y-intercept at 8, a slope of -1. And then I'll do a test point at 0, 0. So that'd give me 0 is equal or less than negative of 0 plus 8. So 0 is equal or less than 8. So that's correct. So I'll shade in the side that has the 8. Our solution area is going to be the area where all 3 of these intersect with each other. So this area here would be our solution area. So any points within here represent how many acres of corns and how many acres of beans he could plant.